Hi there, this is section 2.1 video over relations and functions. Alright, so let's look at what our vocabulary is. We have a lot of vocabulary, so we're going to just do it in sections. And then basically our objectives in this section are to analyze relations and functions and then use equations of relations and functions. So let's go to our first two vocabulary words, one-to-one function and onto function. So remember, a function is a relation with a pairing of the domain and range, the x and y, the input, the output. All right, so what is a one-to-one function? It's when each element of the domain, the x values, pairs to exactly one unique element of the range. That means they don't share ranges. Now, if you notice, in the range C, the element C does not have a partner. That's okay, because every element in the domain, which are 1, 2, and 3, they have their own range. They don't share. So that's a one-to-one. Right? What is an onto function? An onto function is when each element of the range, so now we're going backwards, of the range corresponds to an element of the domain. They can share. So the element in the domain 3 and 4 share the range C. All right? So what is both a one-to-one and an onto? Both one-to-one says, okay, they're both a one-to and an onto. So let's look at this example on the third column. So every domain has its own range. They don't share ranges, so it makes it a one-to-one. Then you go backwards, as every range pair up with the domain. They can share, but they don't have to, but they can. So that makes it an onto, so it's both a one-to-one. So you have to look at them separately. So let's go and look at example 1. They want us to state the domain and the range of each relation. Determine whether each relation is a function. If it is it a one-to-one and onto, both, or neither? So let's take the first example and let's write out what is the domain. That's the first thing you want to do. So it's going to be -6, -5, -3, -1, and 6. Then what is the range of this? It's going to be -9, -7, -1, and 7. Okay, so now let's determine, is it a function? Well, is there any sharing? Well, if you look at the example, this pair here and this pair. First of all, you look at, do you have any duplicate domains? I don't, so therefore, it is a function. So we're going to say, is it a function? Yes. Is it a one-to-one? Remember, to be a one-to-one, every domain has to have its own, they cannot share ranges. However, if you look here, the -5, -9, and 6, -9, those elements of the domain, they share a range. So it is not a one-to-one. Is it an onto? Which says, does every range have a pairing to a domain? It does. It can share, so it's okay. So it is an onto. So this one would be yes. Let's look at example B. All right. Is it a function? So first of all, we look at all the x's. Do I have any duplicate numbers? Yes, here, -1, -1. Do they have the same output? No. So it's not a function, therefore it's not a one-to-one or an onto or both or neither. It's not a function. All right. So I want you to pause this and do guided practice 1A and 1B. All right, we're back. So now we look at the next two set of vocabularies on the front page, and it's domain and range. So basically, what is domain and range? Domain involves all the x values of a function. Range are all the y values of the function. Okay, that's really all it says. So let's look at example. We didn't have an example. Or we can move on. So basically, you're stating the domain and range, and that's okay. Let's look at example 3. Before that, we're going to go to our next set of vocabulary that we're going to talk about is discrete relation, continuous, and vertical line. A discrete relation, and here we'll go to the book, for this one is simply going to be when you have a bunch of points. So a discrete relation is a relation which the domain is a set of individual points. So this is what we have here, okay? A continuous relationship is when you have a relation which the domain is a set of infinite number of elements of the graph, and it can be with a line or a smooth curve. So it's a continuous line because it has infinite number of elements in the domain. Okay, so that's the difference in discrete and continuous. Discrete are just points. Continuous, you can connect it, make a line or a smooth curve. It means it's continuous, right? How else can you look? Taking those graphs, you can test to see if that is a function. You can do what's called a vertical line test. A vertical line test, you can use a discrete and continuous. If the vertical line passes a graph only once, it's a function, like the sample on the left. If it passes it more than once, then it's not a function. It's really that simple. You just take the vertical line test to test to see if the graph is a function. All right. So now we're going to talk about independent and dependent variables. Okay, so relations and functions can be represented by equations. Now, with the variables x and y as an ordered pair. Remember, x is the domain. It's also the independent variable. Okay, so the independent variables are the x values of the domain, of the function, or the domain. Dependent variables are the y values of the function or the range. It's that simple. Then we have what's called function notation, and we're going to see that in just a second. But first of all, let's talk about graphing of a relation. So we have this equation, y equals 1/2 x minus 3. We can determine the domain and range by its graph. So, and then we can determine if it's a function, a one-to-one, both, or neither. So we make a chart as if we didn't know how to graph it, but we should know how to graph linear equations. And here is the graph. You see, what is your domain? So the domain are going to be all the x values. Because you have an arrow here, that means it keeps going continuous to infinite solutions, and here infinitely this direction. The domain is going to be simply all real numbers. So you would say the domain is all real. So that's the symbol for real numbers. The range is all real numbers as well, because the graph, as you see, it does something like this, meaning what are all the x values? If it keeps going on, what are all the y values? Forever and ever, right? Same thing with the x values. That's why they're both all real numbers, okay? So for here, the domain, is it a one-to-one? Okay, so remember we said, do they share, does every value have its own, every domain, L and domain have its own discrete, unique range? It does. So it's a one-to-one. It's an onto. Does every range pair with the element of the domain? It does. So it's onto. So it's both a one-to-one and onto. It is a function, and it's continuous because it keeps going on forever and ever. All right, so now let's look at example 4 on our last vocabulary. Our last vocabulary is going to be function notation, okay? So we already talked about what independent and dependent variables are. Function notation is a fancy way of writing, and f of x is function notation. It's a fancy way of writing y. So instead of saying y equals 3x plus 4, we can put it in function notation form. Really important to know this vocabulary. That is function notation. We're saying f of x. So we're saying, so if I want to put a value in there, f of 3 to find out what y is. So we're saying, what is y when x is equal to 3? So we're going to substitute x with 3. All right, oh, got my plus sign here. So then we have 9 plus 4. In this example, it's going to be 12. So let's look at the example 4. It says, given f of x, y equals 2x squared minus 8, Find each value. So the first one they want us to find is f of 6. So what are we saying? What is y when x is 6? So we say 2 times 6, and because x is squared, so is 6 minus 8. So we follow PEMDAS. So 6 squared is 36, 2 times 76 is 72, minus 8, which gives us 64. Then they say, find f of 2y. So we're replacing the entire x with 2y now. Okay, just because it's a variable, we're still doing the same thing. So it says 2 times what is x? 2y squared minus 8. Now remember, PEMDAS. What does that mean? That means 2y times 2y, which equals 4y squared. So you have 2 times 4y squared minus 8. Oh, sorry, square is gone because we already squared it. And then you multiply this. It's 8y minus 8. Oops, this is square. And that's it, because they're not like terms, you can't go any further. So stop the video, do 4A and 4B guided practice.